Okay, find the voltage drop across resistors. So you have the following circuit. Okay, you have the following circuit. You need to find V1, V2, V3. Okay, so this question can be solved using two methods. The first one, you are going to make use of the following formula. You have to remember this formula. The voltage is equal to the current times resistance. Okay, so you need to know that the current is the same in series connection. Okay, so the same current flowing through R1 is the same current that will flow through R2 is the same current that will flow through R3. Okay, so you need to find the current that is flowing into this series connection. Okay, so you have to find the current. So you are going to use this formula. Okay, you need the current. Okay, let's get the current. So to get the current, you have to divide by resistance. Okay, so that you can cancel. Okay, so what you do on the right, you also do it on the left. Okay, now you cancel this. Now you have the current is equal to the voltage over the resistance. Okay, so the current is equal to V over R. So we carry on. Now to find the current, you need V. You are given V. Okay, V is equal to 15 volt. Okay, you have 15 volt, which is the push. Okay, the push. It's pushing electrons around the circuit. Okay, now you also need the total resistance. The total resistance is equal to, you have 2 plus 1.5 plus 4. This is equal to 2 plus 4, 6 plus 1.5. You have 7.5 ohms. Now you have V and R. Now you can calculate the current. Okay, the current is equal to 15 over 7.5. This is equal to 2 amperes. So you have a current of 2 amperes flowing into this circuit. Okay, 2 amperes. V1 is equal to, you are going to use this formula. V1 is equal to, you have the same current. Okay, the same current is flowing through R1, R2, R3. Okay, the same current. You are going to use R1. Okay, you are using this formula. When you are calculating V1, you are going to use R1. When you are calculating V2, you are going to use R2. When you are calculating V3, you are going to use R3. Okay, so V1 is equal to the current. Okay, the current times R1. Okay, this is equal to 4 volts. Now V2 is equal to, you have the same current is flowing into the series connection. To find V2, you are going to use R2. This is equal to the current. Okay, the same current is flowing into the series connection. R2 is equal to 1.5. Okay, 1.5. This is equal to V2 is equal to 3 volts. Now, V3 is equal to the same current. Okay, the same current is flowing into the series connection. Okay, times R3. This is equal to 8 volt. So you have V1, V2, V3. Now, another method. Okay, you are going to use this formula. Okay, you are going to use this formula. Okay, you replace I when you are calculating V1. You are going to have V1 is equal to R1, okay, over total resistance times V, which is the total voltage. Okay, so when you are calculating V1, you are going to have R1. Okay, you replace I. Okay, you replace I with 1 or with 2 or with 3 or with 4 or with 5 or with 6, depending on how many resistors you have in the series connection. So V1 is equal to, you need total resistance. Okay, you have the total resistance. Okay, so the total resistance, you calculated the total resistance. Okay, okay. Now V1 is equal to R1 over total resistance times the voltage. This is equal to, you have 15 divided by 7.5, 2 times 2, you're going to have 4. Okay, 4 volts. Now, V2, you're going to have R2. Okay, you replace I. Okay, R2 over total resistance times V. Okay, this is equal to, R2 is 1.5 over total resistance 7.5 times V 15. This is equal to, you are going to have 15 divided by 7.5. You have 2 times 1.5. You have 3 volts. Now V3 is equal to R3 over total resistance times V is equal to R3. R3 is equal to 4 over total resistance times voltage. This is equal to 15 divided by 7.5. You have 2 times 4. You have 8. Okay, 8 volts.